Okay, everyone, welcome to day three, derivatives with coefficients. We're going to expand upon the chain rule that we did yesterday, and we basically have our very basic derivatives that we learned already, and we've learned all of these. These are our basic ones, and then we talked about when we add in an extra k value in front of the x, and then we get what I call my mini chain rule. I don't have to do a full chain rule. If my function is sine of 5x, its derivative is 5 cosine of 5x. We talked about this before. If it's e to the 2x, its derivative is 2e to the 2x. So let's talk about how do coefficients affect things. Well, we've done this many times. The derivative of x cubed is 3x squared, and the derivative of 5x cubed is 15x squared. And basically the second one is 5 times bigger than the first one because this 5 coefficient goes along with it. It's just a multiplier. Talked about it many times. Coefficients go along for a free ride. So let's try some of these. These aren't too bad. These are pretty quick and easy. Negative 2e to the x. G prime is negative 3 sine of x. This is going to be 5 cosine of x. And this is 6 over x. This is going to be positive 5.3 sine of x. And then finally, negative 2.75 cosine of x. And those are very basic derivatives using our rules that we've set up before. So when we have this coefficient in front, we know it's going to be a times cosine of x, negative a times sine of x, a times e to the x, and a over x is the basic derivatives when we take put a number in front. But what happens when we have both a number up front and something in front of the x? Well, this derivative before was k times cosine of kx. Well, this a up front is just going to multiply it. They're multiplying each other the same. And then this one is going to be negative k times sine kx. That has to be the same, but there's going to be a in front, so those are multiplying each other. This was k times e to the kx. Notice that exponent is the same, and this a goes in front. Now this k value didn't matter. This was just 1 over x before. But with an a in front now, it's a over x. That did not matter. Let me write that down. This k did not matter. But notice, remember we talked about the argument. Sine of kx is going to be a cosine of kx. Cosine of kx is going to be with the sine of kx. Exponent e is k to the x. This exponent is still e to the kx. That does not change. So none of these are what I call mini chain rules. I don't have to do the full chain rule. I know it's going to be still e to the 2x. That cannot change, but I multiply these two, I get negative 10 e to the 2x. This is going to be, well, it's a negative cosine. It's going to be a positive sine of 4x. And then I multiply them, I get 12 sine. So it's going to be e to the 1/2 x. And I multiply them, I get 2e to the 1/2 x. Let me move this up a little bit. Pick a different color. Well, ln of 6x is still going to be 1 over x times a half, so it's going to be a half times 1 over x. I get 1 over 2x. Is this derivative? Cosine is going to be a negative sine of a half x. That argument won't change. I got to multiply these two, so I get -2.65 times sine of a half x. Then finally, I'm going to do, this is going to be cosine of negative 4x, and I'm going to multiply these two coefficients. I get 11 times the cosine of negative 4x. So I call these mini chain rules. It's not a full chain rule I have to go through every single time. It's basically keeping the argument after the trigonometry the same, keeping the exponent on each of the same, and kind of multiplying that coefficient in front of the x times the coefficient in front of the function. Okay, thank you for watching this video.